Good evening and welcome everyone to today's session, which is a continuation of our sensorial lesson. The last two exercises in the Montessori sensorial materials, that's the binomial and the trinomial cube. So today's first part of session, we're going to divide it into two parts. Okay, so we're going to see two of the materials. The first one is binomial cube, please note down. And the second one is called the trinomial cube. Now, what is this material? When you look at the materials itself, you should be able to tell me that these are colorful cubes. You can see multiple colors, isn't it? We can see red color cubes, we can see black ones and the blue ones. These are the cubes that you can actually see. But is it a cube? No. The cube, whatever you see it as a whole, is divided into multiple cubes and cuboids. In this combination, when you're putting the cubes and cuboids together, it is going to make up another cube. So that's the simplest concept. Now, see, suppose in case if I give this to a student who is like 3 years or a 4-year or a 5-year, would they be learning the mathematical concept or would they be just identifying these are simple cubes? Just like our simple hands-on exercises, try to stack on one on top of the other. But in case if the same material is given to slightly older children, like around 6 years or 7 years, in your primary classes, the children will start to understand that cube can be made of multiple smaller cubes and cuboids when they are put together. Okay, so that means the child is able to understand. So a little older children, maybe like once they're around 8 years and 9 years, when they're introduced to the concept of algebra, you can also teach them that this binomial cube is nothing but it is representing an algebraic identity. Okay, there are multiple purposes of using this exercise. One is like you give it to the younger children, so they are working this as a puzzle cube. They are going to put all the cubes and cuboids together to make a larger cube. If they are little older children, probably they understand how exactly to make it. But if they are still older, we are introducing them to the concept of cubes and cuboids. So all of these conceptions is what the child is going to learn. The structure, what we're going to see is how many such smaller cubes should be there, how many cuboids should be there, how do we arrange them in the specific pattern, why is that there a specific pattern of colors, why is it that there are red-sided faces, there are blue color figures, there are black colors, or some of them are combinations, we would be able to see them. These colors, guys, are going to help our children to assemble these cubes correctly. So visually, they're very pleasing. And of course, we would learn the formulae. Okay, what is the formulae that we're going to learn? It is a plus b the whole cube is what? Our a cube plus b cube plus 3a square b plus 3ab square. How do we get to this derivation or to this particular algebraic formula is what we're going to see in our step-by-step process. Okay, let's understand. So we are going to focus on the visual sense first. Then we're going to give each of the cubes and cuboids for the child. Let them hold the cubes. Let them hold the cuboid. Let them get the tactility. They get the tactile sense. Now they are going to arrange each one of them. They're going to apply logic. Which face has to touch which face or which color has to touch what color. Okay, that's going to be the rule that we're going to see it. So let's get started then. So you're all good to go? Okay, so again, I just wanted to quickly remind you the goal of early childhood education should be to activate the child's own natural desire to learn as told by Dr. Montessori, and we have to reinforce this particular lessons. Take a look at this. This is our binomial cube. Once the child puts everything onto the mat, you will see the smaller pieces. Now, can you define and tell me how many cubes should be there? This is a cube. Is that a cube? Yes. And this is a cube. So we have only 2 cubes here. Correct? What about the other ones? What about the other
rectangular prism?
Rectangular prism. 2, 3, 4, 5, and 6. So we have 6 cuboids which has rectangular faces. Agree or not? We have
yes.
over here. Now what we need to come over here is like having a deeper understanding about how many cubes, what is the color, How many cuboids? What are the colors? What are their sizes? If you start understanding this spatial reasoning, and if you start putting all of them into as a puzzle piece which can actually fit in so that it becomes as a cube, that is what is our entire intention all about. Okay, so that's what we're going to see. It's a very simple algebraic expression that we're going to be working on. So now let's take a look. The box will have one red cube and three red and black matching prisms. What is a prism? Prism is nothing but a rectangular prism is nothing but a cuboid. Okay, a rectangular prism is a cuboid. Cube is a cube. Okay, so there are combinations. Now you can take a look. So we have how many red and black prisms? 3, right? Can we see here? This is a red and black prism. This is a red and black prism. This is a red and black prism. Everybody, 3 red and black?
Yes, ma'am.
Good to go. So 3 red and black prism. What is a prism? Prism is nothing but a cuboid. A rectangular prism is a cuboid. Now what do we have? We would have 3 black and blue prisms.
Yes.
Correct? Yes or no?
Yes, ma'am.
This and this one. So we have 3 black and blue prisms. So this is our description. What's the next thing? We have one
Square.
red cube, not a square. It's a cube.
Sorry.
Right? So we have one red cube and we have one blue cube.
Blue.
So this is our material required. Now you're able to identify. Everything is easy for us to understand. So we have 3 red and blue, red and black, 3 black and blue, 1 red and 1 blue cubes that we're going to have. That's our material. Now, can you take a look at this? The materials required. I'm so sorry. Now, can we figure it out and tell? We have 1 red cube. Yes. 3 black and red prisms. 1 blue cube. 3 blue and black prisms. Now, when you assemble all of them, what is that we're going to get? We're going to get the formula A plus B the whole cube. That's the whole intention of doing this exercise. So what should we do now is you bring the material, take a tray, go and bring the material, keep it onto the mat. Now is what we're going to find out the formula. Okay, let's start to decode. So be with me. So let's take the first red cube. Okay, now the height, I'll take a blue color here. Okay, this is one parameter. This and this. This is also my A. This is also my A. This is also my A. The length into width into height, all of them are same in a cube. Length and height and width are all same. So I can say this as A cube. When I'm trying to find out the volume of that cube, it is A cube. Correct? Now let's take another cube. This, and this. Since the size is different, I'm taking that as a parameter B. B, this is also B, this is B. Length into breadth into height. So that is my B cube.
Yes, ma'am.
So this is our B cube. So we could decode what that cube is. This cube is A cube. This one is B cube. Now we need to find out for the other ones. It's very simple. Now take a look at this. Since it had red color, so it is A. Since it had red color, this is also A. That means my height and my width are all of the same parameters, but only this is differing. So what should I say? It is A into B. How do I write this?
A square B.
That's A square B.
Yes.
Now let's take a look at this one. So this is same. This is also same. So again, this can be my A. This can be my A. This can be my B. So again, that is also A square B.
Yes.
Now let's take a look at this. This and this are same. So that means this is B. This is B. Only this parameter is varying. So that's my A. So I can say this as B square A.
Is correct.
Yes?
Yes, ma'am.
This is same. This is same. So this is again my B. This is my B. And this could be my A. So
B.
again, this is our B square A. So how many A square B's I have?
2.
2.
2, ma'am.
2 A square B. Correct?
B.
So how
Yes,
many
ma'am.
B square A's I will have? 2
2.
B square A's
Yes,
I
ma'am.
have. So we have decoded this. Now take a look at this one also. We left this, guys. This is again my A. This is my A. This is my B. So this is also my A square B. Yes? This is B.
Yes, ma'am.
This side is B. This side is A. So what is this? This is B square A. So that means I have 3A square B, 3A square B square A.
Yes.
Correct?
Yes, ma'am.
So we have
Yes.
Yes, ma'am.
all the cubes and cuboids. So we are good to go. That's the formula. A plus B the whole cube is what? A cube plus B cube plus 3A square B plus 3B square A. That's all. So all the puzzles put together, it's going to be our formula. So what did we do over here? We tried to work on the relationship between all the parts. It could be my cube or my cuboid. When I put them together, it's going to give me a cube, a bigger cube. That's what's the entire formula all about. So this is important. So whenever you are trying to help us during your examination, every cube or a cuboid, you take it out and you have to tell them what is that parameter. Okay, how should you be able to describe the formula? This is the only thing that you're going to be working over here. Now see, if I'm trying to put everything together, this is how it is. Okay, so I have A square B, and then I have AB square, and my B cube. Correct? So this is what we need to be working on. So you got the entire binomial cube. So when you put all these pieces together, we are going to get this formula A cube plus B cube plus 3A square B plus 3AB square as our formula. Okay, so that's the formula. We are going to get that back. Easy, right? Very simple. And if you get this, it is a scoring exercise. You need to draw a cube. Probably you can explain them about the parameters, how you're going to define and all of that. Okay. So that's the visual representation because it becomes easier. One quick trick for all of us is like you need to segregate them according to the colors. Keep the red color cubes, red color prisms, blue cube, blue prisms separately. So you would be able to judge it easily. And that will also be one of the representation for our child. Now let's see how we could actually build this formula in the real way. Okay, so there is a technique of how we do that. So for children, when we are trying to help them to work on these exercises, we teach them the visual representation of how exactly that we could be able to work on. It's easy for the adults to understand, but when it comes down to children, they might have a little troubles working on this. So I just wanted to share you. Am I able to share my screen?
No, ma'am.
I think I got some network issue. Can you hear me?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Yeah. Okay. So let me quickly share the binomial cube with all of you. Okay. What's the first thing that we do here? We lay out a mat. We ask the child to either sit or they come down directly using this. Take out the material and there is a way that you open it. You gently open it using your gentle hands. The first thing, randomly put everything. So arrangement does matter. So we had the cube. We are having the cuboids. That's the prisms. We're going to segregate the black and the blue one separately, right? So what's the next one? So
Right.
these are all our prisms. Okay, these are all our prisms. Now this is a cube. Keep it on the red. Now what you got to do here is like you need to now work on the pausing. So you need to work on the directions, or you should work on the colors. Now take a look here. What is this surface here? It is red color.
Mm.
What is the surface that I have here? It is our black color.
Black.
So you need to choose something which is of a combination of the red and the black. So what should be my red and the black? It is my cuboid. So I take this because it is red. So black has to touch the black and the red will have to touch the red. Now again, I have the red surface and the black surface. We need to be putting them together. And now at the last one, it has got the blue combination, my black and the blue. So we take over here the black and the blue, and then you need to make sure that the black surface touches the black side and the blue surface touches the blue side. So this is the first layer, okay? So once you have completed the first layer of construction, you transfer it. Now you got to do the second layer of your construction, wherein you start with your blue cube. Always start with cubes. Take your cube. Now cube has all-sided blue color. Now take something blue and the black combination. So make sure that the blue surface touches the blue and the black touches the black. Now do you see that there's a height difference?
Yes.
Yes, there's a
Yes,
height
ma'am.
difference, right? So this is slightly lesser in height because you're horizontally placing. You did not place it vertically. The first combination, we did place it vertically. The second one, we are trying to put it horizontally. Okay? Now, this is the only difference. If you're putting it vertically, the blue cube will be tiny. It wouldn't have the same level. Okay? Now, you transfer your second levels. Now, that's going to be your cube. That's all is your exercise. You're trying to build a cube using multiple pieces of cubes and cuboids, and you would derive your formula. Easy? That's binomial cube. Similarly, we work on the trinomial cube. Now, say suppose in case if you have your trinomial cube, we need to also understand what is trinomial and why should we use it. Just like our binomial cube, it looks very much similar. But again, now it comes with how many parameters? It comes with 3 different cubes now. It would have its red cube, it would have its blue cube, but you will add another tiny one, the yellow cube. Okay, so it would be now, earlier we did only a plus b the whole cube. Now we are going to do a plus b plus c the whole cube. Okay, easy, right? So we're going to be working only on that particular part. So before going to that, let's understand a bit more about what is trinomial. Now, if you start counting the number of pieces, you need to make sure that this trinomial cube is slightly complex. You need to get that because it's not that easy as our binomial, because now you need to make up 3 layers. So this is made up of how many pieces? 27 pieces. 27 pieces would be there to make up this binomial cube. Now, what are the colors? We usually have red color, blue color, yellow color cubes. Okay. Now, how about the structure? Now, when I take this entire cube, again, I would subdivide this cube into smaller cubes. I can have cuboids. I can have rectangular prisms just the same way as my binomial cube. Now, what are my children supposed to do? They're just going to assemble all these cubes. They're going to sequence all of them. They're going to arrange all of them. That means there is the first exercise that we're going to work is on sorting. That means visual discrimination. Anything which is got with red color, we sort. Anything with the blue, we sort. Anything with the yellow, we sort. That means the first exercise is completely done. So what am I trying to work here on the visual discrimination, wherein applying logic, applying the sizes and the spatial awareness, my children are going to sort them. When they are trying to work on sorting, don't you think there is also a fine motor skill? The child is able to handle different sized pieces. They can identify. And at the same time, on a higher edge, we are trying to work on higher mathematical conceptuals. So start with binomial. Only if your child is good enough in understanding binomial cube and is able to come to the formula derivation, then only you would move to your trinomial cube. That's the easiest part of telling it. Okay, let's see now. Just like our binomial, you need to figure it out. Put all the cubes and cuboids down, one after the other. Put them randomly. The next thing what we need to understand is we need to see how to divide these things. Now, what is the first thing that we're going to have is we will have how many cubes? 3 cubes, correct? First one is a red cube. I got the red cube. Then we would have a blue cube and then we would have yellow cube. Then we would have 18 square-based prisms, out of which 3 are red and black combinations, which will be of the same height of your blue cube. These descriptions you got to write. Next, we would have 3 red and black, but the height will be slightly smaller of that of a yellow cube. Okay. Next, we would have 3 yellow and black of the red cube height, 3 yellow and black of the blue cube height. If you do not know to describe this, take the material, see what is the height of those prisms. Once you keep it together, you should be able to figure out the height of it. Okay. Then we would also have 3 cubes, that is the combination of my blue and black, which will be of the height of my yellow cube. Apart from that, we would still have 3 blue and black, which will be of the same height of red. That means 2 red heights, 2 blue heights, 2 yellow heights prisms is what we would have. That's going to have. Now, that is my 18. What about the other ones? We still have 6 black rectangular. Okay. Apart from these, we would also have completely black rectangular prisms. Completely black. It is not with any colors. They are completely black rectangular prisms. Okay. One out of which a pair is of with red, the size. The pair is of with the blue size and 2 of them are of the yellow sizes. Okay. Now we would form all of these cubes so that we would be able to make A plus B plus C the whole cube. Let's start layer by layer. The first one, since it's the red cube, the height of it is slightly bigger. Then you start with your blue cube, the height is slightly smaller. Then you start the last layer with your yellow cube, the height is slightly smaller. So that's the reason you have different variations of combinations of all of these, which will match to each of their heights so that they all come into one level. Clear, everyone? The material. So let's see one layer of the other. Okay, this is how the formula is going to be. Now say this is my parameter A. Now we know, right? This is A. This is A. This is A. So this is A cube. Okay, everyone. So this is A. This is A. This is B. So what is this? This is our A square B. Now this is my
A.
C. This is my C. See, the thickness is slightly smaller. Thickness of B was slightly big here. And look at the C parameter, the thickness is slightly smaller here. Correct? 1 second, please hold on. Sushma? Yes. So that's our the third prism. And now take a look at the next one. So this is again our A. This is A. And this is B, right? So that's our A square B. Now, if you're taking this, this is my B, this is B, and this is A. Why am I taking this as B? Because the height of that is same. Okay, so that's the reason it is considered to be as my A. Now, if you see here, everything is different,
Yes.
correct? So one could be, this is my C. This is our A. This is our B. So this is ABC. So likewise, take a look at all of that. This is A, this is A, this is C. Look at the C. Wherever you see C, this
It
height is very tiny it is. So this is our C, this is our B,
B.
and this is our A. Correct?
Okay.
Now say this is my C, this is my C, and this is A. Slightly longer is A, medium is B, and very tiny is our C. So every layer by layer, when you're trying to pick up all of these cubes and prisms, you need to decode the formulae and write what it is. So probably what you get is like, you might get this as a worksheet, you might have to write the parameters. So this is my, not the entire formula. This is just the first layer. Okay. So what did we get in the first layer? A cube. Then how many A square B's? How many A square B's? 2A square B, 2A square C. Then
2AB square.
2AB square. Next,
And 2AC square.
2AC square. And 2
And 2
ABCs also.
Yes.
Right? So we got this. So try to decode for your other layers. Okay, so we got this as my first layer. I'm trying to put everything into my first layer. We decode the same for the second layer. I don't think I have to do this. So now you're all able to do on this, right? So we work on the second layer. We work on the third layer also. So once we have all the three layers, we put together the formula. This is my first layer, where I'll have A cube, ABC, A square B, A square C, A square B, B square A, then
ABC,
ABC, then A
A
square,
square C,
then again ABC, then AC square. So you put all of these layers together. This is my first layer. This is my second layer. This is my third layer. When you put all these layers together on one on top of the other, we get the formula. And what's the formula? We had 3A square B's, 3AB squares, 3AC squares, 3AC squares again, B cube, 3B square C's, 3BC squares, 6ABCs. See, in every cube, we had 2 ABCs, 2 ABCs, and then we had 3 C square, sorry, C cube, right? So this is our equation. So its only thing is like, how well that we should be able to decode. So have a comparison between your binomial cube equation and the trinomial cube equation. Every equation, whatever we're trying to get it, the child should be able to remember the previous ones. So this is the equation that we're going to be deriving. So what's the first step that we do? We're going to sort out. So sorting is important. So you try to put all of the sortings. So everything related to our red, all the 6 black prisms, combination of my blue and black. Look at the height variation. Now, can you see the height variation? This is taller, this is shorter. This is shorter, this is taller. This is shorter, this is taller. Right? So 2 different height variations. You should be able to get it. Okay? So that's the arrangement. Then build layer by layer. The first layer, if you see, it's the tallest one. The middle layer, and then the last layer. Okay? So how to build each of the layers? I'm just going to show it to you. Okay? So just be with me.
This question can be expected for theory exam.
We usually have not got it, but yeah, in case if you get it, usually they don't ask binomial. This is completely on the total practical, right? So they usually don't ask such questions. There are questions which can be related in practicals being coming in theory, like explain with the help of a 3-period lesson, how do you demonstrate the concept of length or thicknesses, something like that you might get. So you have a choice to choose whatever material that you find it is feasible. Okay. So these ones, they will precisely ask in practicals only. Okay. But a very scoring topic if you know it really very well. And this is how we do it. And yeah, 3 layers. First thing what we do is we sort everything, completely sort it out. So we have all the combinations of our black and yellow. Now you have a blue combination ones. Completely black ones, you sort it out separately. Take a look. Let the children also know about it. This presentation, you need to do it really wise so that the child also gets the visual discrimination. This is done. Now take the first layer. So we have a complete red cube. Now check on the surfaces, a red and a black combination. So you need to choose something which has got the red and the black. Next, what you do, you need to match with the height of the cube. Okay, so those should be the matching. Now again, a red and a black. I got to match with the red and the black. I need to match it with my cube. Now I got to have my red and black again. So I choose my red and black again. Now if you see, it is thinner compared to my B. So that was my C. My C had come there. Now a combination of my red and black, but slightly thinner. Now take a look. We have something with blue and black. Choose something of the blue and black here. But it is not the cube. We don't pick the cube there. Now it is blue and, black and black. So you have to choose the black prism there. Now again, black and black. Again, choose the black. You need to check what is the face that it is touching. Last one is yellow and black. Choose from the yellow and the black. Make sure the height is all constant. Touch the surface. Everything should be of the same height. Now you transfer it. Okay, so our first layer is done. Now let's do the second layer. You start with your blue cube. Check with the blue cube. Take the blue cube. Always start with the cube. Now go around. A blue touching black. Check from that. Match to the height of my cube. So you will know how to put it. Next is my black touching black. Okay, you continue with that. Yellow touching black. Okay. Now the last one is red touching black. So what should I do? I bring that and it is kept horizontal. So our second layer is done. We transfer it back onto the second layer. Okay. So the lid of it acts as a base for construction. Okay. So try to construct on the lid itself. So children will not have confusion. Now start with your yellow cube, the tinier one. Again, always yellow touching black. So you need to reinforce the same. Make sure, now I can't keep it vertical, because the height will differ. So I flip it horizontal, right? So you need to check on that way. How do you place the positions? And if everything is black touching black, you take your rectangular prism of completely black color. And then you finalize it with your other red prism. That's our third layer. That completes the trinomial cube. Why do we do this exercise? What is the purpose of doing this exercise?
To teach
To
algebra.
know the
Yeah, go ahead. It's a math concept. There's so much of
Algebraic
logic,
to know
identity.
the
algebraic expression. Yes,
to know the formulas also.
very good.
Really, sensorially teach the concept.
And know the height and
Sensorially teach the concept.
Yeah, to understand the height, breadth, and length. Okay.
And here
know the colors also.
Colors. Okay.
There is like two concepts in math also, like cube, cuboid, geometrical and algebraic identity. We can go together.
Definitely. So that means the concrete foundation for your abstract math.
Yes.
You could put it
Maths.
that way, right? Yeah. Yeah. Formulas. Yes. See, when nobody taught us the formulas like this, no, when we studied. We still
Yes, ma'am.
don't know. We still don't know how did we get all these formulas, but we actually learned it in that way. So, yeah, that was there. So we never.
We did by heart at that time.
Yes, we by hearted it, and we still do not know where do we use all those formulas and why did we actually use it. We never knew. We knew the precision of it, but we did not know the base of how the formulas was actually being taken care of. See how beautifully it is being done. So we are trying to bridge that sensorial exploration with the mathematical concepts. Okay, so that covers the two of the exercises that we had not done. Okay, so let's join back for the art session. That will be our part 2. Okay, connect back.